Okay, welcome back to Soils and the Environment. We're going to look at soil survey and web soil survey this morning. And I will specifically show the web soil survey part of it, and that's what this session is about. There are a few preliminary things, but then we'll go into a live session on web soil survey. Keep in mind that you want to look at Conquer and Franzmeier chapter 10. Make sure that those concepts are covered. We should cover most of them today, but there is information in Conquer and Franzmeier that I want you to make sure you do. Rather than my trying to regurgitate some of Conquer and Franzmeier's stuff, there's a guy called Charlie Ogg that's a good friend of mine. He's also a really good soil scientist, got his PhD from the Hokies, and he's mapped over 1 million acres of soils. So I don't think there's anybody more qualified to tell you about making soils maps than Charlie, and so this URL is over here, and of course you can just link to that in your notes. So that's kind of what I wanted to cover in terms of making soils maps. Let Charlie do that, and he's got a world of experience out there, and he can kind of talk to you about those things. That's also going to be part of what you'll be responsible for. Before we continue on to sort of this live demo, we need to remember the limitations of soils maps. If you have a look what Charlie's talking about, soils maps are made at a large scale, 1 in 20,000. So they're based on large areas that are selected from topography, vegetation, water features, and things like that. Usually the smallest feature that you will find in a survey, a soil survey, is going to be 5 acres or more. So I want you, while those lines between the soils are drawn and they appear to be extremely precise, they may not always be accurate. So be aware of that. Again, the web soil survey is something that you can use on a large scale, but when it comes to making small scale decisions, you really want to go in with your soil auger and make sure that you understand what you're letting yourself in for. Make sure that what is said in the web soil survey is in fact true on the ground. There's this issue about inclusions that you can see here, and what that's saying is, in a soil series, say we have a Cecil soil series out there, and it might be say a 20-acre mapped or sort of a 28-acre polygon. You may have inclusions of other different soil types in there, in that Cecil soil series, and that might be for a variety of reasons, possibly a low-lying depression, so it might be some kind of a wetland soil. But remember that if you have a 20-acre mapped Cecil series, you might have a variety of 1-acre inclusions of soil series that are series other than the Cecil, and that is very common. So again, be aware of those limitations on the map. I think web soil survey does that quite well. Let's go ahead. When we're reading the soil symbols, these are some of the symbols that you're going to come across over here. The first 2 letters, a large and a small letter, are always going to refer to the soil type or the soil series. Over here, the Barnwell sandy loam, and so this is just nomenclature that comes to it. This would be, for instance, a Coxville. This would be a Goldsboro Johnson. So that's kind of those are assigned prior to it. And remember, soil series are usually series that are assigned names based on the towns that they were discovered, or some kind of geographic feature that they were discovered close to. Okay, The second symbol, that large capital letter over here, A's, B's, you can get C's and B's as well. That is for slope. The next slide covers what kind of slope you have. But so you have the soil series. Those are the first two letters. The next one, this big letter over here now, is the slope. And then the third letter is the amount of erosion that goes on, or that they see in that soil. If there is no number, it is assumed to be a 1. So the Coxville sandy loam with an A slope and there's no number after that, means that it's not the erosion is negligible. Let's go ahead in our next slide and have a look at those symbols over there. So you have slope classes A, B, C through G, and these are the percent slopes that you would have in them over here. Okay, usually, you know, for any kind of agricultural use, you're not going to want to try and farm on D slopes, for example. Certainly not do row crops or something like that. And when you're building on D and E slopes, of course, you have engineering issues that you need to deal with. The erosion classes, negligible, no symbol implies 1, we've just talked about it. Moderate erosion is 2, and severe erosion is 3. So we're talking, the soil survey has happened over the last 100 years, and for instance, we know that, especially in the southeast, where you had maybe 175 years ago, where we see forests right now, that was all in cotton. And we have, most of our soils have been fairly badly eroded in the last 150 years, and possibly even before then. When we got our hands on large-scale tractors and things like that, of course, that we were able to put more acreage under production, and we saw more erosion as well. Okay, in the old days, you'd have soil surveys, and each county office of the USDA would keep copies, and you could go in and ask for one. And it was a big old book. It was about this size, and you know, it was pretty much like a telephone book, and it had maps, and it had then soil descriptions. Today, we're much more used to online Adobe Acrobat files, and these are soil surveys over the whole area. But the web soil survey now is so much more simple for us to get at, because usually we don't necessarily want to know what is happening in a whole county. Often county lines are so artificial anyway. Web soil survey allows us to kind of zone in onto an area of interest and then go from there. So that has just become a lot more convenient. Soil surveys contain general information, so you get a general map. They contain your detailed soils map, map unit descriptions. So in other words, for each map unit, for each soil series, it'll give you a description of that soil series. You know, what that soil looks like, you know, up to 2 meters below the surface. Gives you a little bit of technical information, and it gives you soil interpretations. The technical information might be things like sort of the average pH or the average cation exchange capacity. Now, you need to take these numbers with a pinch of salt, because the average pH of a Cecil soil or a Goldsboro soil, that's kind of a movable feast. So it changes from one to the other, but at least it gives you the ballpark of what you're looking for. Same as cation exchange capacities. And you can look at those and then compare that, say, to what you've got on the ground. But don't assume just because it says the pH is 5.3 that every time you go out and see a Goldsboro soil that the pH will be 5.3 or 6.3 or whatever it would be. The soil interpretations are interpretations that soil scientists have made for a number of different uses, land uses. There are now huge interpretations for military use, for example. The original interpretations were for agriculture, and that would be for row cropping and then pasture. And then more recently, it's things like military, housing, for instance, can you build a house with a basement? So construction, can you build a septic tank? How is that going to work out for you? So there are many interpretations, and we'll have a look at some of those interpretations as we go through this today. So with that, I'm going to exit to Web Soil Survey. I'm going to go to my browser, and in fact, before we do that, I'm going to go back. Best way to do it is go to your favorite search engine, click Web Soil Survey, and go to the home, and you want to hit this button over here, and that's going to start the Web Soil Survey up. All right, so here's the Web Soil Survey. Now what you can see, you can click in an address, and I'm going to have you do something where you go to an address and that you will home into a specific, a very small area. You can go state and county, and then you can also soil survey area, but this one may be quite over here, latitude and longitude. You can actually, what I often do is get the lat long from Google Maps and then copy and paste that in here. You can do these other things are there as well. You can even do it in hydrologic unit area, but I usually do lat long, state and county, or address. So I'm just gonna, for the sake of looking at a variety of soils in an agricultural area, I'm going to go to South Carolina, and I'm going to go to Lee County, just because that's kind of where we might see something. I click the view button. Now this takes a little bit of time, but that's actually not too bad at all. So this is Lee County, and you can see that it's a fairly large extent. If you had to do an area of interest right now, it would bomb out on you. So you have to zoom in a little bit. You can see that's your scale at the bottom. And let's go ahead and use that little plus button there. I'm going to begin to zoom in a little bit, and I'm going to zoom down into St. Charles. I'm zooming in there because I've been on that particular site and I know those soils. So zooming takes a little bit of time again, but there we are, actually not too bad. Not too bad at all. Okay, for some or other reason we've got a little blank spot here, but that's okay. Okay, so you can see obviously this area around here, there's a tremendous amount of agriculture that's going on. But what you can also see, you can see fields with green on, and then fields that are fallow. Presumably this aerial photo was taken in the winter, where you might have some winter wheat growing and then fallow fields over here. But what you can also see then is part of this is forested. You can see that. And there's some wet areas, wet patches there as well. I'm going to move up here. That should work for us. I'm now going to draw my area of interest. You have two choices. You can use a rectangle, or you can use a polygon area of interest. I'm going to use the polygon just to show you how that works. And let's suppose that I have an area of interest. Perhaps I know that the property lines of this property look like this, and maybe this guy's property goes down to the river and then back up along this road. Well, let's include this, say And this should be small enough for our area of interest. Okay, so once I've closed that polygon, I'm going to double click and it creates an AOI, or an area of interest. And so that's basically the area that it's going to be looking at in Web Soil Survey. So I'm quite pleased it's actually going quite quickly. Just before we carry on, a couple of things. These are your navigation tools. This hand tool is your pan tool. If you wanted to zoom to full extent, I think it'll take you back out to the county, or maybe even the country extent. That will allow you, I think, if you zoomed in very, very closely. Well, let's do that and see what happens if I zoomed there. So I'm zooming in really closely. If I wanted to get back to my AOI extent, it brings me out here. And then the other thing, zoom history back, it'll take you to the extent that you were. So let's zoom back out here. So that's kind of some of the stuff. This little thing will identify, and this little thing allows you to measure distances, for instance. So you can actually measure, this is very much, it's an online GIS. I'm trying to see where, oh, there we go. If you have a look at the bottom, okay, I'm just going to move this up a little bit. If you have a look at the bottom here, it's measured these segments over here. So you can see what that distance is. And in this case, he's put it in meters. Oh, and there's feet and miles as well. So that's quite a nifty little online tool. 10 years ago, features like this online would have been unheard of. We've created our area of interest. Let's go into the soils map itself. Now what you've got is you have a soils map, and all of your soils are now shown here. Remember, we talked about those soil symbols. For instance, the GOA, as far as I remember, would be a Goldsboro, and it's an A slope, so it's 0 to 2%. That's not surprising out in Lee County. It's pretty darn flat over here. So over here, you have your soils map. Isn't that cool? For me, that was way cool when I first saw it. It's such a great tool. And over here, what you have is a list of all of your soils, how many acres there are for each soil in the area of interest, and the percentage of that area of interest over here. So it gives you all of that, gives you your total acreage. So I've got 1,400 acres, which is, a reasonable area of interest. Once you get down to an area of interest of much below, say, 5 acres, you really have to sort of take things with a pinch of salt. For instance, in your exercise, you're going to do that, and we'll talk about that in the field, because that's going to be something that you bring with you. Okay, so let's have a look at what else we've got on the screen. You can see to measure a distance, so it gives you a few instructions. Over here, it's given you your soil map, but now it gives you a soil description. So here's an Ailey Troop Vaucluse. I'm not familiar with that particular soil, but it's telling me this is what that soil looks like. This is where we're going to find it. It tells you what sort of landform it is. It's a marine terrace. Soil slope, it tells you what the slope is. Farmland classification, not prime farmland. And here's my profile. So this is 0 to 8 inches. That's my A horizon. It's going to be a sand, 8 to 22 inches sand. And then you can see the various horizons. This is probably going to be, a B, an E horizon, a BT horizon. It might have a BF horizon or whatever, but this is kind of what you've got. This 65 to 80 inches coarse sandy loam might be some of your parent material, or the parent material might be below that. Interpretive groups, we talked about interpretations. I'll go back there a little bit later. For this, It's not prime farmland. Hydrologic soil group A means it's very, very well drained. Very well drained, not really a good soil. Let's go to something that that might be more conducive to farming. Well, in fact, what you can do is zoom in a little bit now. Okay, so he's farming in this area. You can see that he's got NE would be the Naboco. A Naboco is a soil that looks a little bit like a Norfolk and a little bit like there's another one. Naboco is actually kind of a mix between two soils. One of them is Norfolk, and I can't remember the other one right now. But you can see this is where the farmer is farming. Now, if you have a look here, you've got a Naboco, you've got a Norfolk sandy loam over here with inclusions of these rains. Sometimes, can you see these little low spots, or sometimes you can see different shades? I think this might be an area. So he's farming this, but over here you can see a rain soil going there. Let me just go and try one more. A Norfolk soil, a Norfolk sandy loam. This is going to be a slope, and this kind of gives you an indication of what this soil looks like. Well drained. It's prime farmland. It's got a very high land capability 1, which means it's very suitable for farming. Hydrologic soil group is that it's well drained. So very well drained or extremely well drained is that sandy soil that we saw. And then if you have a look, this is your profile. 0 to 7 is loamy sand. That's that's going to be your A horizon. 7 to 15 inches is also loamy sand. Maybe that's your E horizon. And then your B and C horizon are fairly deep. So it's a deep, well-drained soil, very suitable for farming. So I think you've got the picture over here. Really nice way to look at your landscape and look at your soils. Let me just zoom in over here. You can see that the farmer is farming the Norfolks. There's a little bit of rains. That rain soil is well, let's go to the rains just for. The rain soil is a hydric soil. In other words, if you dig down into it, you'll see a gley. And let's have a look. Where's that rains? Okay, there it is. It's of statewide importance, but the land quality capability is 3W. 3W just suggests that it's a wet soil and it's not quite ideal. The hydrologic soil is B/D. Its soil group is B/D. So it does suggest that the rain soil is not very well drained. And when you dig down into the soil, you will see that it's got a that gley comes out fairly quickly at about, oh gosh, probably down beyond about 20-25 inches. But you can see over here he's farming his Norfolks. He's avoiding that rains there because it's maybe too close to the river. But this MY, what's the MY? He's not going to farm that, and neither is he going to farm that Jonesboro, which is right down here. It's not going to be really suitable for farming. It's going to have a water table that's too close to the surface. And so we can have a look at that in a minute. So that's so much for our area of interest. Let's go to that Soil Data Explorer. So we've looked at created the area of interest, looked at the soil map. Now let's go to that Data Explorer. I want you to look at Soil Data Explorer. It has several tabs. So it's got the introduction to soils. You can kind of click this and get a number of selected topics that you can kind of read about. Okay, so that's kind of cool. the suitability and limitations of use is the interpretations that we spoke about earlier. And you can see they're classified into several different things, including military operations, as I said to you. So for instance, if we wanted to, I think the one that I like to use, the sanitary facilities, is you have a look at this, and you know, where can I, in this part, where can I best look at septic facilities? Well, let's go ahead and have a look. I'm just going to do that. Is there nothing else I need to click? View the rating. And it says, you had better not put septic facilities in these soils, for instance, and let me just zoom in again. So don't build septic facilities on those soils, because we'll have a look at another one very quickly, is because your groundwater is too close to the surface, and so if you put a septic system in there, you're always, you know, for the wet part of the year, you're going to have that flooded. So that rains is flooded, and then what you can do is kind of look at some of those interpretations down here. These are somewhat limited. There are none of them that are highly suitable. Many of them are very limited. The Norfolk, if you go back up here, that's somewhat limited. Look at that rains, and the Jonesboro. Let's go to Jonesboro. You can see it's very limited, and over here it's flooding. The depth to the saturated zone on average is 1 meter. So you're really not getting very good, you know, you're not, with depth to the saturated zone of 1 meter, your septic tank's going to leak a whole bunch. So that's, let's have a look at something else over here. Let's have a look at vegetative productivity. Now, in many of the South Carolina farms, your crop productivity index doesn't work. So let's not worry about that too much. Let's look at water management. Explore those at your leisure. Let's have a look at soil properties and qualities. Look at water features. Depth to water table is what I was thinking of. Let's zoom out to our area of interest. There we go. And I'm going to say depth to water table. And I want to view my rating here. And you can see various things. Let's have a look at those colors and on what the colors mean. Basically, your ALE troop Valcluse that we talked about. Now, what is that? NNA. What is that? Naboco complex is rating. Depth to the water table 91. So you can see. And then the yellow, I think, would be, oh, that is the yellow there. Okay, so that's the ACC, oh, that's the green over here, is going to be deeper than that. And I'm trying to look for the A, that symbol over here. But, so your green is going to be your soil that's the best drained, or the highest distance to the water table. And then, oh, that ACC right here. So you can see that blue part. Okay, wait a minute now. That's interesting. Okay, so that's the most well-drained soil. That doesn't seem intuitive to me, because that's along, oh, this is water here. And this looks like the ALE over here. Your soils with the depth to the water table, let's look at that. Jonesboro and the rains. 16 centimeters, and the Jonesboro basically 0 centimeters. So they're saying that's basically a wetland. It's a hydric soil. It's a wetland soil. It's going to be flooded most times of the year, or at least sort of 40 to 60% during even the dry season or the growing season in the summer. So that's a kind of a nice feature. Let's quickly have a look at some of the soil chemical properties. Again, be very, very careful about how you interpret this. But for instance, looking at the cation exchange capacity, Over here I would include my top depth from 0, say, to 30 centimeters. That's 1 foot. Let's make it 15 centimeters. That's 6 inches down. That's kind of your, what we call the plow layer, and it comes up. These are your cation exchange capacities. Now, a rating of 0.7 milliequivalents per 100 grams is extremely low, and these are a lot of your sandy loams. You can see even your Norfolk over here. It doesn't contain, oh well, that's a 2, doesn't contain all of that much organic matter. And cation exchange capacity is how many negatively charged sites there are in that soil that will attract cations. Cations being potassium, potassium, calcium, magnesium, and sodium. Okay, and we talk about that quite extensively in soil chemistry. So that also gives you an idea. Again, be very, very careful of how you use this information. These are averages, but based on the land use and how that soil was treated, you could find some very, very different interpretations on that. You can see that rain soil, because it's a mucky soil and low-lying, your cation exchange capacity naturally in the rain soil is a little bit higher because it contains more organic matter and higher concentrations of clay and organic matter, both able to do that. Soil erosion factors is another thing you can get. Your K factor. K factor is your soil erodibility index. It's kind of something that was empirically derived. So each soil, they would put it on a 22% slope, bare soil, and then they would run a certain amount of water over that, and it gives you an erodibility index to put in your universal soil loss equation or revised universal soil loss equation. Again, something that we'll look at later. So 0 to 15, let's have a look at that. Run this, see what we've got. So we've got some of the soil, some of these things are fairly low erosivity factors. Some of them are fairly high. So that Coxville set, let's have a look at the highest. The Goldsboro sandy loam, 0.24. Coxville sandy loam is 0.2. Goldsboro is 0.28. Coxville is 0.24. Oh, the Doravan silty loam is 0.43. Let's see where that Doravan is. The BOB. Okay, so, oh, that's interesting. The colors seem to be inverted over here. So the BOB is the lowest erosivity index. And so let's have a look what the MYA is. 0.32, that's the highest. So interestingly enough, I would have thought that the colors would be different, that your highest rating would be red because that's more erosive. Anyway, so that you're able to go in now and get some of these data for average soil qualities. Remember, it's average. So let's have a look. Soil physical properties, available water supply, available water capacity is right here, and that's another thing that we'll be looking at in our soils and water. So it really is a very useful thing as long as you understand that this gives you average numbers. When it gets to be site specific, you then have to be careful about that. One of the features that I want to now take you to is if you want to, for instance, have this particular interpretation, you need to add it to your shopping cart, and you can say K factor or whatever, Buzz, whatever you want to do, and you want to learn how to spell properly. Okay, so there it is. And maybe we want to go to a water feature, depth to water table, view rating. There it is, and we add that to the shopping cart. Okay, Now once, and the shopping cart, it's free. So why they call it that, I have no idea. Let's go to the shopping cart. And over here in the shopping cart, you can then check on this side what you want. You see we already put the K factor and depth to water table. Let's go back to the Data Explorer one more time and let's just look for suitability and limitations and say building site development, dwellings with basements, okay, view ratings. And now we add that. You can see you're not going to want to build a house with a basement down in these red areas. Add that to the shopping cart, okay, and then go back to, where did I go? Shopping cart. It says free there, so it kind of, and we can give it a custom subtitle, ENHS 793. And now we are basically, now you can see the dwellings with basements were added, so we are good to go. Now what I'm going to do is check this out, and I'm going to say get now. Now this process takes a little bit longer than normal, and so I'm just going to probably splice this part out. Alright, so what's happened now is that it has generated this Adobe Acrobat file. File, save as, save it on the desktop, ENHS 793A or 793. I'm saving it. There it is. And you'll see that that whole report now sits here. It's got a little table of contents, and all of the things that we did are in here. So that's your soils map. I mean, you can't get much better than that. Your map legend, your map unit legend. So these are all your mapping units. Each soil series has its own mapping unit with the slope and then also the erodibility, and none of them has a higher erodibility than negligible. These are your soils descriptions for each one, and then suitabilities for land use. They actually give that each of the suitabilities is there. Again, it gives a map unit legend. So it really is to me a very, very valuable tool, especially for instance for people doing evaluations on somebody who wants to buy a piece of property, you know, a farm or a small holding. You know, I've got 20 acres. What's that look like? Well, you can come to something like Web Soil Survey and kind of dig around and at least get an idea, get a feeling for what soil types there are, and then go ahead and verify that on the ground. So I hope that this has been a useful picture for you of how to use Web Soil Survey. I think it's a fabulous tool, especially when you're doing that kind of work. I'll be giving you opportunities in the class to use it a little bit more. Thank you very much, and